When we draw a Lewis structure, such as the Lewis structure for carbon tetrachloride or carbonate ion, we are distributing the valence electrons between all the different atoms to make bonds and to give some of the atoms some lone pairs. So for instance, if we draw the Lewis structure for carbon tetrachloride, we end up with a structure that looks like this, where each chlorine atom has 6 lone pairs. And there is a bond between the least electronegative atom carbon and each of the chlorines. If we draw the Lewis structure for carbonate, we end up with a Lewis structure that looks like this, where we have 1 double bonded oxygen and 2 single bonded oxygens. Now, the electrons have been distributed among all the different atoms. And the question we want to ask now is, are any of these atoms more negative than the other atoms because of the number of electrons that they have around them? And to do that, we're going to use the concept of formal charges. And this is just a way of keeping track of where the electrons are in the molecule. So the first thing we need to do is to be able to count the number of electrons that are associated with any given atom in the structure. So for instance, in carbon tetrachloride, this carbon atom has 4 bonds. So it has 2, 4, 6, 8 electrons around it when we're counting for the octet rule. But when we're counting for formal charges, we don't want to overcount electrons. We don't want to double count any electrons. So we're going to take the 2 electrons that make this bond, and we're going to give 1 to chlorine and 1 to carbon. So for each bond, we're going to give 1 electron to one of the atoms that's bonded and 1 electron to the other atom that's bonded. So this carbon atom, in terms of formal charges, would have 1, 2, 3, 4 electrons around it, because I'm going to count bonds as 1 electron for each atom in the bond. That takes care of both of the electrons in that bond. And then if I have lone pairs, those lone pairs belong completely to the atom that they're on. So for the carbon in this structure, I would say that it has 4 electrons. Now, if I count the electrons in the chlorines, each chlorine has 1 bond, so that's 1 electron, and it has 3 lone pairs, or 2, 4, 6, 7 electrons. So I'm going to say that each chlorine has 7 electrons in this structure. Now the question is, does that make that chlorine more negative or neutral or more positive? So in order to figure that out, I have to think about how many electrons that chlorine brought to the structure. So remember that we're looking only at the valence electrons, and chlorine is in group 17, so it has 7 valence electrons. So each chlorine has 7 valence electrons, and in this structure, it is getting 7 electrons. So it is getting all 7 of its valence electrons that it brought to the structure, so it neither has more electrons nor less electrons, and so it has exactly the number of electrons that we would expect it to have, and that means that this chlorine has a 0 formal charge. If I look at the carbon has 4 valence electrons, and it has 4 electrons in this structure. And so this carbon also has a formal charge of 0, because it neither has more electrons nor less electrons. If it had more electrons, it would have a negative formal charge. If it had less electrons than the number of valence electrons, it would have a positive formal charge. So let's do the same thing and look at the carbonate anion. Remember that this anion has a total 2- charge. So if I look at the carbon, this carbon atom has 1, 2, 3, 4. Remember, this is 2 different bonds, so I give 1 electron from this bond and 1 electron from this bond to the carbon. 1, 2, 3, 4. So in this structure, carbon has 4 electrons, and it has 4 valence electrons. And so this carbon has a formal charge of 0. If I look at the oxygens in this structure, I can see that each oxygen that is singly bonded has 1, 2, 3, 4, 5, 6, 7 electrons in this structure. And so this oxygen atom has 7 electrons in the structure, and this one, which is exactly the same configuration as this one, 1, 2, 3, 4, 5, 6, 7, also has 7 electrons in this structure. The oxygen that is double bonded has 1, 2, 1 from each of the bonds, 1, 2, 3, 4, 5, 6 electrons, and so this doubly bonded oxygen has 6 electrons in this structure. Now remember that oxygen has 6 valence electrons. And so since now in this Lewis structure, this oxygen has an extra electron. It should have 6, but it has 1 extra electron. Its formal charge is -1. 1 extra electron gives it a formal charge of -1. And the same thing will be true for this oxygen. It will have a formal charge of -1. However, this oxygen that is doubly bonded has 6 electrons in the structure, and it has 6 valence electrons, and so this formal charge is 0. Now, what you will notice is that if you take all the formal charges in this structure, so 0 plus -1 plus -1 plus 0, so the sum of the formal charges, add them all up, should equal the charge on the ion or atom or molecule. So in this case, we have 0 plus 0 minus 1 minus 1 is -2, and in fact our total charge is -2. So now I know that I've counted my formal charges correctly. If I look at this carbon tetrachloride, all the formal charges are 0. The molecule itself has a 0 charge, and so when I add up all the formal charges, I get the charge on the molecule, which is 0. And that's how we do formal charges. That's how we count formal charges.